Okay, so we just took a look at an introduction to graphing lines and parabolas. So now let's take two equations, y equals x plus 1 and y equals x squared minus 1. Remember, I'm using really simple examples so you can get the steps and then you can apply them to more difficult questions. So again, last year we did 5 chapters of graphing, and the last one was systems of equations, where we could apply principles like substitution and elimination. So let's do that here. So we know y is equal to this, and y is equal to that. So what can we say about this and that? Well, we know that they're equal to each other. So x plus 1 equals x squared minus 1. So let's get it to be 0 equals. Check the notes, see all the adding and subtracting steps. Get more comfortable with your algebra. X squared's positive on the right-hand side, so I want to leave it on the right-hand side. That's why we say 0 equals. So x squared, then I want to minus x from both sides to get the x on the left to the on the right. So I'm going to minus x from both sides. So minus x. Then I have a minus 1 on the right. I have a plus 1 on the left. I have to get it equal to 0 on the left, so I have to minus 1 from both sides. If I minus 1 from both sides, minus 1 is minus 2. Then I'm going to factor it, so I get 0 equals. Two numbers that multiply to get negative 2 and add to get negative 1. Go back to grade 10 and factor. Are negative 2 and positive 1. Set your factors equal to 0 separately and solve. Get your answers. X equals 2 and x equals negative 1. Our answers. So now we have our x values. Well, remember from last year, we substitute one equation into the other, then we solve for a variable, then we take those x values and we put them back into the easier of the two equations. We solve for y, and those are our intersection points. So let's take the easier equation down below, always rewrite it. Y equals x plus 1. Now remember, there's two x values, so I'm going to write that again side by side, just so I don't accidentally forget to do the other point after. So I'm going to put x equals 2 into this equation and x equals negative 1 into this equation. So we get y equals 2 plus 1, y equals 3, immediately the intersection, x 2, y 3. The equation on the right, taking x equals negative 1, substituting it in, y equals negative 1 plus 1. I would have substituted with brackets if it was more complicated. Y equals negative 1 plus 1 is 0. Immediately, the intersection point, negative 1, comma, 0. Circle your answers. Those are the two intersections of this line on the left, y equals x plus 1, and this parabola x squared shifted down 1. So that's algebra. Remember, we always do algebra, and then we always graph things. So let's shrink that up a bit. So now let's take the equations down below, rewrite them. And y equals x squared minus 1. X plus 1 and x squared minus 1. Draw a graph. Remember from grade 11, the line y equals x plus 1 is the line in the form y equals mx plus b. Write that down if you have difficulty with this. We have a y-intercept of 1, so I'm going to put a y-intercept of 1 on the graph. Then we have a slope of 1, up 1 over 1, up 1 over 1. Go back to grade 10 and learn how to graph things. We did 5 chapters last year on graphing, half the year. Okay, now we took the parabola x squared, which usually has a vertex at 0, 0, but we're going to go down 1 to be a y-intercept of negative 1. At this point, it would be any type of transformation. Left, right, up, down. If you forget how to graph it with the table of values. But we know it's 1x squared, so we can do the pattern. 1 squared is 1. Symmetrical point. Point of intersection. Circle it. Back to the vertex. 2 squared is 4. Circle a point of intersection. Symmetrical point. Draw the parabola. Label the intersections. The intersections are top right, 2, 3, and bottom left, -1, 0. Circle your answers. How do they compare to the answers that we got above? I pointed to the wrong ones, but yes. So we can do it by algebra, and then we can do it by graphing. If you get different answers, this allows you to go back to the method that you were least confident about and try and find the error, allowing you to teach yourself how to do so much algebra at home. Be confident with your better method, know it's good, and then try and shoot for those answers better. Okay, so that's graphing a linear and quadratic. And now let's do a quadratic, I think. Oh, interesting, yes. Okay, but before that. Now, we started off with two equations at the top in big red. Y equals x plus 1 and x squared minus 1. And we graphed them both down below, the line and the parabola. But at some point, big blue, we factored and found solutions, which we did in previous chapters, and those were x-intercepts. Now, what is that all about? Well, if I were to graph those x-intercepts on a graph down below, following big blue up, we have x-intercepts at 2 and -1. So I'll draw those on the graph. At 2 and -1. Excuse me. Perfect. Okay. Then draw a parabola, just because we don't really care about the rest of it. So just draw a little parabola. Now what you notice in big red is that the x-intercepts of the third equation that was created by substitution, above where blue is pointing to, the x locations of the x-intercepts are exactly the x values of the intersection points between the line and the parabola. So we take one and we put it into the other. Some form of substitution and elimination. Solve for the x and the y values, then graph them in y equals, if you can manipulate them to that form, and then make sure the answer is the same. Now, keep in mind, I'm going to go on to another example, which is quadratic, and it's just an interesting case that we just want to remember. So before that, I just want to remind you, this was substitution. You might have had to isolate for a variable and then substitute. Go back to grade 10, solving systems, and learn how you do the basics and then just apply them to these. So no matter what equation they give you in any form it is, you always just know the steps. Substitution, isolate, substitute, solve. Again, substitution, isolate, substitute, solve. These equations, y were already isolated, so it was very easy to substitute them into each other. But you might have to do some algebra and manipulation of rearranging the order of the terms to do proper substitution and elimination. Okay,